mhtx.com is the web page, and very, very interesting. So Dr. Flynn has advanced his study and science to a level of maturity, and we've been engaged to bring it to the market.
What is the biggest challenge in bringing something like this to the market? Ed's been working, you got mice level, human trials.
Yes, I think the biggest problem, the biggest challenge, as you say, is that the world resists change. Most everybody resists change. It brings to mind a little story. The Wright brothers had to bring their heavier-than-air flying machine in front of the U.S. Patent Office in Washington, D.C., 17 times to demonstrate it to the patent officers before they would believe it. And the analog here is that Dr. Flynn's technology is very much a breakthrough and a radical new way to view cancer and the super early detection of cancer.
Absolutely. Using magnetism and nanotechnology and attracting it to the cancer cells themselves. Ed, what got you started on this track? How did you connect all these dots to put this together?
Well, my original career was a nuclear physicist, which makes it sound a little strange.
It does.
I published about 175 papers in nuclear physics. And then I had the unfortunate circumstance of my first wife having a cardiac arrest and going into a coma for 18 months, and I got interested in the brain after she had died. And so I used my expertise in magnetism from nuclear physics to develop some schemes to measure magnetic fields from the brain, which I did for almost 20 years again, my second career. And then my second wife got breast cancer.
Wow.
And so then I started thinking, is there a way I can use similar techniques for finding breast cancer? And the way was to use these very tiny little magnetic particles. And because we have this extreme sensitivity for magnetic fields, we can find minute amounts. And so if we injected them in the body and they targeted the cancer, we can find them in
Interesting. So
small.
basically, you inject this in, and it goes and attaches itself to the cancerous cells.
It injects itself, it attaches to cancer cells and cancer cells only.
And then you follow it and you say, there's the cancer.
That's the cancer. And we can then, by measuring the magnetic fields coming out from those nanoparticles in a method called magnetic relaxometry, we can locate where the cancer is and how many cancer cells are there.
Wow.
I'd like to add something, Kathleen, if I may, and that is that recently the New York Times ran a story about a study at the Komen breast cancer survivor.
Susan G. Komen, right?
Yeah, Susan G. Komen. And what they reported was that some 90,000 women had cancer surgery operations, very serious operations, and none of them had cancer. So the difference is that while the pathology involved in finding breast cancer tends to be sometimes subjective, here 90,000 women having surgeries.
And they didn't have breast cancer.
They never had cancer. This was learned later. Now the Flynn technology has 0 false positives. 0, not 99.9, 0 false positives. Those 90,000 women had false reports. And Ed, you can explain a bit more about that and technically.
Yeah, like what is the difference then? I guess because of you're getting an X-ray or kind of taking a picture of a tumor, and then you interpret whether it seems cancerous, and then you do a biopsy and you look at the cells. But your technology, again, is doing something that is kind of more profound and more at the level of the cell.
That's correct. I mean, by injecting these magnetic nanoparticles into the person with these targeted antibodies, they just go through the system and they don't do anything unless they find cancer, and then they attach to it. So one cancer cell on a tumor will attract 200,000 of these small nanoparticles.
I guess, as much as people worry about X-rays, right, and the radiation risk, I could say, well, gosh, you're going to start injecting me with magnetic stuff, and is there a health risk? I mean, I guess that's partly why you do the human trials.
Well, that's right. That's where we're going. The health risk, For example, some of these magnetic nanoparticles are using in MRI, which many of you have heard about, as a contrast agent. You're allowed to inject up to 5 milligrams of iron per kilogram of body weight. We need 1,000th of that. We are 1,000 times less than is allowed for injecting iron into a person. And our sensitivity after we do that, so we can detect 50,000 cancer cells in the body. It takes 200 million before a mammogram sees it.
And this could detect other kinds of cancers. This isn't just for breast cancer.
That's correct. We've been talking about breast cancer, but there are known antibodies for ovarian. And we have an ovarian cancer study funded by the National
Hard to
Cancer
detect
Institute.
as well.
Hard to detect and usually deadly by the time it's observed.
We are taking a look at a new technology that holds great, great promise in terms of fighting cancer. Breast cancer is the one we've been talking about, and let me just throw out some numbers. For example, in 2006, the average cost for treating women with breast cancer was $37,000. It is multiply that across the couple of 100,000 people who seem to come down with it each year, at least, and the numbers are large. But of course, it's really the human aspect. It's the loss of life, not just from breast cancer, but all kinds of cancers. It really does seem to be one of the scourges of our lifetime. But I'm speaking with two men who have a new technology, a new method for detecting cancers way earlier than we're detecting them now with conventional X-rays that they have developed and are bringing to market. Ed Flynn is president and CEO of Senior Scientifics, a long distinguished career in nuclear physics, in brain science, and now with nanotechnology and magnetism to detect cancers. Marvin Maslow, chairman emeritus of Manhattan Scientific, he has been guiding these nascent promising technologies to production, to market for many years, and they are in a partnership. Marvin, tell us how you and Ed got together. What drew you? You must get so many proposals, right?
Yes.
That you have to turn down. So when you say, oh boy, we're doing this, what is it you see?
Well, a little bit of background on that. We work in northern New Mexico, which is the home of the two great nuclear laboratories, the Los Alamos National Laboratory and the Sandia National Laboratory. Each of those labs employs about 3,000 PhD scientists and about 7,000 support staff. That's quite a lot of very, very smart people. And at a lunch meeting about 16 months ago with the chief scientist of all these scientists at the Los Alamos lab, and that's J. Thomas Bowles, B-O-W-L-E-S. I said to Dr. Bowles, I said, you've been here since Noah was a boy. What was the most exciting, most profound, world-changing technology you've ever seen? And he said, that's simple. That's Ed Flynn's work. Ed Flynn holds the promise of totally altering some of the most dreaded diseases on the earth. And that's how I met him. I picked up the phone and called him and told him who I was. And a couple of weeks later, we had lunch together, and we enjoyed meeting each other, and we started working together.
Well, this is a very, very, very exciting partnership. Ed, you said their next stage, you've tested this on mice. Now it's going to go to human trials. If I might be out there listening, I might have somebody in my family with cancer, breast cancer, and I'm thinking, wow, I'd like to take advantage of this. What does it take next? How long to go from where you are now with this to actually having something that comes to market that we can find in hospitals and doctors' offices?
Well, we first have to find a larger partner that can that does this kind of work, takes these technologies out to clinical trials.
And let me expand on that if I can, Ed and Kathleen. That is the business model used by Manhattan Scientifics is a model that allows us to work hand in hand with a large, big pharma or big medical device, large industrial partner, Fortune 50 type partner. Rather than try to do it ourselves and as an early startup and so on, and most of those fail, as you probably know. Our model is to work, is to hitch your wagon to a star, is what I like to say, and work together with a big company.
Do you have one lined up?
We have quite a number that we have begun talking to. Mm-hmm.
Okay, so you get the big star, you hitch your wagon, and how long does this take? How long till this is actually a reality that I can have my doctor prescribe that I go and get this kind of test?
Kathleen, it's not months and it's not decades. But the timetable will very much depend upon our big industrial partner and how quickly they want to step on the gas.
So realistically, to go for the clinical kind of testing that we have to do for breast cancer, it'd be about 3 years. Now, we're already doing a leukemia study where we get bone marrow from leukemia victims, and that's in clinical trials. And we've developed a far more sensitive way to measure how much leukemia is left after chemotherapy. We're 50 times more sensitive for determining how much chemotherapy can be used. So that by using our very sensitive sensors and magnetic nanoparticles, we're really changing the way they measure minimal residual disease for leukemia. And what that means is you can much more precisely decide how much the leukemia patient needs in chemotherapy.
So this isn't just detection, this is treatment as well.
This is treatment. This is affecting the therapy because chemotherapy is mostly a shotgun approach. You do the standard regime, but some patients varies considerably between that, and you really want to minimize that, especially in children. Children who get leukemia are 70 to 80% chance of being cured, and they'll suffer severe loss in IQ and short-term memory problems the rest of their life. So you have to minimize the chemo, and that's our goal by this part of our technology.
Terrific goals, terrific findings. Marvin, if someone wants to learn more about this, the technology, what's going on, where do they go?
Marvin at mhtx.com.
and we can certainly Google Ed Flynn and find you.
It's seniorscientific.com.
Seniorscientific.com. Very good. Gentlemen, thank you so much.
You can subscribe to Bloomberg's premium podcast service at Bloomberg.com/Tom Keene and listen to the Hayes Advantage weekdays at noon Eastern on Bloomberg 1130 in New York or on satellite radio, Sirius Channel 130 and XM Channel 129. Copyright 2011 Bloomberg.